Hello, and welcome to the University of Georgia's Division of Academic Enhancement's Online Academy. My name is Will Pearson, and today we'll be talking about converting skeletal structures of cyclohexanes into their corresponding chair conformers. The chair conformer is a more accurate representation of what the molecule looks like in real life, and by making this conversion, we can more easily see the spatial relationships between these substituents on said cyclohexane. In order to properly convert our cyclohexane skeletal structure into its corresponding chair conformer, we first need to be able to draw the base of the chair conformer properly. To do so, we're going to want to draw two parallel lines vertically. It should look something like this. Once we've done that, we want to connect this point with this point. But, as you probably know, we need to indent it. It should be indented this way and slightly down. Again, we want to do the same thing with this point and this point. To do so, we're going to put our node somewhere in here. When you're done, you should be left with something that roughly resembles a bow tie. Now, if we think about this in 3 dimensions, and we connect these 4 carbons, they form the flat part of our chair, of our lawn chair. If we were to look at this structure from this angle, we would be left with something that resembles that, or as one might call it, a lawn chair. This carbon lies down here, while this carbon lies up there. As you can see, this carbon and this carbon are out of plane with the other 4. This carbon right here and this carbon right here are eclipsed over each other right there. This carbon and this carbon are eclipsed over each other right there. Based on this diagram, you can see where the name chair conformer comes from. Now that we know how to properly draw the base of our chair conformer, we can start to map the substituents from our skeletal structure onto the base of our chair conformer. So the first thing I need to do is to draw the base of the chair conformer, like so. Now, using the IUPAC numbering that I applied to this skeletal structure, I can use those numbers to keep my carbons straight and to match up the substituents in my chair conformer. So you can pick any carbon you want on your base to be carbon 1. I am going to choose this carbon right here as carbon 1. Then from there, you can count either clockwise or counterclockwise. It does not matter. So I'm going to choose this carbon to be number 2, and this one to be number 3. Now, I know that I have an OH group, or a hydroxy group, on my first carbon, so I map that directly to the first carbon of my chair conformer. Now, I know I had a methyl group on my skeletal structure of carbon 3. Therefore, I know that I have a methyl group on carbon 3 in my chair conformer. So, I add my methyl group. Now, this representation is the same as this one. We have drawn our chair conformer from our skeletal structure.